Hello, my name is Robert Margina. My presentation is on NBA players' heights and how it plays a role with certain metrics. Thank you all for watching. So, to sum up why I decided to pick this topic, it's basically just because basketball is a sport that's played by tall people. It's known to be one of the biggest advantages that you can have in the game, in certain parts of the game especially, which kind of makes sense when you think about it, because the hoop is 10 feet tall, so it's naturally just easier to put the ball in the basket or to like rebound and miss if you're taller. Also, fun fact, while the average American is 5'9", your average NBA player is standing at a whopping 6'6". I also saw another statistic the other day. It was something like 20% of all 7-footers in America play in the NBA, which like that's just crazy to me. But anyways, so the objectives of this model are to develop multiple models to see if we can find a relationship between height and performance in the NBA. This will be done through multiple linear regression. And then we want to compare each of these models to see which one is the best. And finally, we are going to interpret the results of that best model to see which variables can predict height the best. So the data that I am using was acquired from Kaggle. However, that particular data set was just raw data that was scraped from the Basketball Reference website, which is one of the primary statistics websites for sports. They post virtually every stat and advanced metric out there about every player. I would have gotten it straight from the website myself, but unfortunately, they don't have that feature anymore where you can like extract the data. I think it might be paywall, which kind of sucks. But anyways, this particular data set has all the basic statistic totals as well as demographic information about pretty much every player that played in the NBA in the 2014-15 season. So that is a total of 490 players in this data set. So I just wanted to show a snippet of the raw data set so you guys can just get a feel for it. I had to split into two so it could fit on the slide. But you can see here it has the totals for all the main statistics. So rather than the common points per game that most people refer to when they're like talking about stats, like basketball stats and conversations, it has the total points accumulated by each player in the entirety of the season, which in our case is better because it's easier to measure. And you can also see that most of the demographic information is located at the bottom end right there. You have like birthplace and college, and right there is where our all-important height metric is located. You can also see that height is measured in centimeters, which kind of makes sense because it would be harder to measure and analyze using feet and inches. I don't really know why we do that in America, but so as you just saw, the initial data set has quite a few variables, specifically 33 in total, 28 of those being continuous variables and 5 of those being categorical. Since a lot of the data is irrelevant to being able to like predict height or do anything with height, like most of the demographic information was, I just removed all of those and I only kept the ones that possibly pertain to height or NBA performance. I also removed variables that had like too much overlap. So, for example, I kept points, but I got rid of field goals because in order to score more points, you have to score more field goals. So it would have just been overlap and it could have potentially been too confusing and do something to the data. So I just got rid of it. And for whatever reason, some of the players didn't have a height listed. So I got rid of them as well. That brought down the sample size from 490 players to about 420. Another important thing I did to the data was altering the variables to become per minute. So basically, I figured that because there are probably some tall players out there, who played a little amount of minutes in the season, so they have low totals in each statistic, and that can give us results that we don't want. So what I did was I took each of the basic statistics, the total statistics for each player, and I divided them by the total minutes that that player played in the season. So, for example, rather than having total rebounds, you're now going to have rebounds per minute, which that's a much smaller number, but it makes it much easier to compare against each player now that you know that minutes played is not a factor. And you can also see it on the graph here. On the left is total rebounds is the variable, while on the right is rebounds per minute. And you can see there's a much more clearer and more defined trend for the right graph compared to the left one. Excuse me. So now on to the variables. Now that the data set is modified and ready to go, we have a total of 11 variables. Obviously, height is going to be our response variable, so the other 10 here are our predictors. We have points, which basically you just get points for putting the ball in the basket. You have rebounds, which this is when a player grabs the basketball after a missed shot. You have assists, which are given when a player passes the ball and the other person makes a shot. The person who passed the ball gets an assist. You have steals, which self-explanatory. It's just stealing the ball from your opponent when it's in their hands or in their possession. You have blocks, which that's also self-explanatory. It's blocking or altering the shot when the opponent tries to score. You have turnovers, which it's when you give up possession of the ball. So usually that's like when you get your ball stolen or if you go out of bounds. And then there's also personal fouls, which are when you do an illegal act and the referee blows his whistle, that's a foul. So these last two, turnovers and personal fouls, you're gonna want less of them. So less is better with these two. Uh, then you have field goal percentage, which is the total amount of made shots divided by the total amount of missed shots. Um, and it's the same with 3-point and free throw percentage, the made 3-point and free throws versus missed. Um, Free throws are shots that you get after getting fouled, and it's 1 point each, and 3-pointers are uh, what you get for making it behind the little arc. So moving on to methodologies, I created a total of 3 models to compare. As I stated before, these models were created using multiple linear regression. I used LM and R to make these. So height is a response variable and everything else is the predictors. The first one, I just made a base model with all the predictors in one just to see how it would turn out. You can see in the equation it's got everything from points to free throw percentage. Then there's the second one, which is a backward selection model. This model ran a total of 3 times, removing a variable each time one by one, and it came out to be points, rebounds, assists, steals, blocks, turnovers, personal fouls, and field goal percentage. And then the last one I did with forward selection, this one ran 6 times, added a variable each time, and it came out to be rebounds, assists, blocks, steals, field goal percentage, and turnovers. So on to the results. You can see in this table here are the AICs of each of the 3 models, as well as the adjusted R-squareds. So for the AIC for the base model is 2618.942, backward selection is 2615.398, and forward selection comes in at the lowest at 2614.813. And all the adjusted R-squareds are similar, so with these results, we're gonna have to go forward with, we're gonna have to go with the forward selection as the best model because it has the lowest AIC. I also wanted to take a closer look at the forward selection model to see how it analyzed each of the variables. So looking at the coefficients, we see that blocks is the clear strongest of the bunch at plus 83. It has the largest coefficient of the variables on here. The second and third place are steals and assists. However, unlike the blocks, they both have a negative coefficient, which means that as they go up, your height goes down. Also, in that last column, you can see that all the p-values are below 0.05, meaning that they're all statistically significant. I also just wanted to add a correlation plot just to reference how the model picked compared to the correlations of each variable. So what's important to look at here is this top row, because it's correlating height with each of the variables. You can see that the top three strongest correlations here, which are the biggest and the darkest circles, other than obviously height on height, it's rebounds, assists, and blocks, which coincidentally enough are three of the top four strongest predictors in the previous model. Also, looking at the colors, blocks is blue, which means a positive correlation, and assists and steals is red, which means a negative correlation, which that's just the same as the signs were on the forward selection model. So, in conclusion, the forward model came out to be the best one according to the AICs, which it had the lowest of with 2,614.813. I think it's fair to say that this model is a solid one, given the similar results that it had compared to the correlation matrix. And the top four variables that the model picked are blocks, steals, assists, and rebounds. And I think further analysis should be done on other physical attributes, such as like wingspan or weight, because this is something that NBA front offices, especially like scouts, when they're looking at young players coming out of college, they put a lot of emphasis on these physical attributes. It becomes like a big factor in their decision making on who to sign or draft or whatever. So we need to see, it's important to see if these are actually impactful or not. But that is all. If you have any questions, feel free to email me at gw5597@wayne.edu. But otherwise, thank you guys for watching this presentation, and I wish you all a happy holiday season.